Hi everybody, I'm here to do the lesson 13 practice problems. It says, here are two polygons. Select all sequences of translations, rotations, and reflections below that would take polygon P to polygon Q. So I got some tracing paper here, and the first one says, rotate 180 around point A. We're on this triangular paper instead of your normal grid paper like this, right? On this paper, each of these angles is 90. On this paper, each of these is 60. So 180 would be 3 triangles worth. So I kind of extend it, right? Here's A. So 180 would be, if I extend this, that's got to land 1, 2, right? 3 triangles over here. So I'm going to turn this. Is that on top of polygon Q? Absolutely not. No. Okay, rotate 60 clockwise around A. That'd be 1 triangle's worth, so I'd need to land right here. So rotate 60, okay. And then reflect over line FA. There's FA. That's this line right here. So then reflect. Is that on top of that polygon? No. All right. Translate so that A is taken to J. So I'm going to slide this so this lands here. So here we go. I'm just going to slide so that lands there. Then reflect over BA, this line right here. BA. See this line? Is that laying on top of that? I could also have just folded it. And I went like this. This is getting messy now. Sorry, guys. And then fold over this line like this. See how that lands right on top of Q? Ding, ding, ding. Let's start with a clean one. It says select all, so I don't know how many there are. Okay, the next one says reflect over line BA. So here's line BA. So I'm going to just flip it over that. Okay. Then it says translate along directed line segment BA. So then I'm supposed to move it this far. 1, 2. 1, 2. Did that line right up onto, yep, polygon Q. All right, last one. See if we can do it with this one I drew. Reflect over BA. Okay, same first move. And then rotate 60 counterclockwise around A. So I gotta land when that lands here. It's partially overlapping, but it's not exactly the same. No. All right, moving on. It says the semaphore alphabet is a way to represent the alphabet with flags. Trying to find a clean piece of paper here. Here's how to signal the letter Q. Describe a transformation that would take the left hand to the right hand. So I'm going to draw my coordinate right through here, my coordinate plane. And I want to know how to get this one to this one. So maybe you can kind of see, like, do you see how if it was 1 whole quarter here is 90. So I know I have to travel all this way, which is 90, but then I also have this much to go, which is half of that. So that's 45, so 135 degrees. There's 45, 90. Wait a second, Miss Austin. Should I draw that line? Do I have to go this? after the 135, I thought it was just going to be a rotation. You have to rotate it 135 degrees, and then we have to reflect it, right? $135, but then it'd be facing up, so then we would reflect. So we're going to rotate 135 degrees counterclockwise, and then reflect across the right arm. All right, here we go. All right, translations. Sorry, Miss Austin's a little slow on the uptake today. Match the directed line segment with the image of the polygon transformed, or the image of polygon P being transformed to polygon Q by a translation by that directed line segment. So I'm just going to draw P and that's it. Just trace it once. And then, so, I mean, you can kind of tell, like, for example, this one right here. This is moving P and then it goes down to Q. What's the only one? Like, look, can you tell if I go like this and trace the directed line segment? No, that's kind of hard. You see how there's P and it got moved by this much. So I can tell translation 4 goes to letter C. And then you can kind of tell, like, look at this one. This one is like, if you line up this point to that one, it's straight across. That's probably the furthest one. So that looks like D. That looks like this one right here. D goes to number 1. C went to this one. And then which one? Now we just have these two left. Look at, for example, number 3. See how it goes quite a bit up, but this one is just almost straight across. So you can tell B is the directed line segment for number 3, and A, that's the directed line segment for number 2. Right? You're just looking. This is how much the slide was and in what direction. So you can look. This one went this way. This one was my easiest one because it was the only one that was going down. Oh my goodness, my camera. So sorry. There we go. Okay. Number 4. Draw the image of quadrilateral ABCD when translated by directed line segment V. Label the image of A as A prime, the image of B as B prime, the image of C as C prime, and the image of D as D prime. I mean, you don't really have to have tracing paper at this point. You can tell you're supposed to move it. Look, count. 1, 2, 3 in this direction. So see this one? You're supposed to move it 1, 2, 3. This is the new C. I didn't need to draw that, right? And then this one is 1, 2, 3. That's my new D. B would be where? Oh, wait, where's here? That one's there's A. And that one's straight across. Let's see if that looks good. You could take patty paper too if you wanted And then you could look, I mean, with colors if you wanted. See that pink line? It's the same length as that. That's your directed line segment. That's how much you slid the whole object. Number 5, here's a line L. Plot 2 points A and B which stay in the same place when they are reflected over L. Well, if I'm going to reflect something over L, the only way it's not going to move is if it's on the line. A and B. Plot 2 points C and D which move. Well, if I put a point over here, C, and I reflect it over this line, it's going to land over here. As long as the points aren't on the line, they're going to move. Here's D. If I reflect across this line, that D is going to end up over there. We're skipping 6. And one more. Here's a review question from our last test. This straight edge and compass construction shows quadrilateral ABCD. Is ABCD a rhombus? Explain how you know. Well, it looks like these 3 circles all have the same radius because BA is the same as AB, and BC is a radius of circle C, which we already know was congruent to the radius for circle A. So these 3 circles are all congruent. They have congruent radii. And then if you look, because of that, and these are all radii of those circles, which are all congruent. So these 4 sides are all the same length. All 4 segments are congruent, so it is a rhombus. Hope this helped. I'll see you soon.